Tatyana, over to you. Hi there. My topic is the in-house cloud container security in the Dzen example. I would like to show you the open source solution using the practical experience. I'm Tatyana Khurtina. I'm a programmer in the inner automation group from VK. Most of the IT companies use containers for deploying the infrastructure for their products, but you may want to understand that the images of the containers can contain errors and vulnerabilities that may damage the entire system's performance. Although the use of the containers has become the main DevOps practice. But what's happening in the world? Take a look at the slides where lots of containers in prod are shown. 87% of the containers in prod have high or critical vulnerabilities. Only 15 of them are in use at runtime. The vulnerabilities come up each and every day, but it would not be expedient just to fix each and every one of them, because not all of the vulnerabilities can be exploited. If we combine a few criteria of vulnerabilities, like, for example, amendments, the use of the runtime, and the ability of being exploited, only 2% of vulnerabilities remain as exploitable. Very often, third-party components are used in libraries, but the quick question of the security is whether you can trust them. The developers possess quite a lot of resources, but not all of them are without vulnerabilities. For example, if the developer comes up with a PIP style, it's not obvious that there are plenty of package substitutes. If you create fake packages with similar looking names, it's very popular, and some of the vulnerabilities that are shown on the slide look similar to you. If you don't know where each library is used, we don't know where we can apply to eradicate these problems. And if we cover the vulnerabilities, it's not going to be that important. For instance, if this is working in the isolated part of the system. All this leads us to the logical need of having the throughput monitoring to look for critically important vulnerabilities and having a comprehensive security of the functioning application. If we make this process right, you can control the security of the infrastructure and react faster to the incidents. But the question is, how do we properly arrange and technically initiate the runtime monitoring? It's the wrong slide, by the way, especially if it's a complicated system with lots of components. So let me tell you that I'm sorry, once again, I confused the slides, by the way. So again, I would like to say a few words that you can check the vulnerabilities in the pipeline, but it's a slow approach. The time for collection increases if this collection ever reaches successfully. But if there's a failure, if the developer will have to single out the time, spend the time to fix, it will reduce time to market. So the developers will have to be given the opportunity to keep on developing. The critical vulnerabilities should be defined by the analysts, not by the scanner. And the vulnerabilities database updates each and every day. So today we don't have any vulnerabilities, but tomorrow it may be detected. So you need to regularly scan the services launched, and if there is a need, you may want to eradicate such vulnerabilities. So let's go back to what I said about runtime 2 minutes ago. We have a different meaning here, speaking about runtime. We are talking about in containers in the real time, almost in real time. On the next slide, I will be speaking about Dzen. In Dzen, the security is on the proper level. So we constantly take measures to maintain it and improve it. So what about Dzen? Dzen has non-standard infrastructure developed in the cloud with a hierarchy structure. Zen runs dozens of thousands of containers, and there are thousands of unique images with hundreds of different dependencies. To address the security issues, Zen uses the FIB architecture. They analyze it and set up tasks for information security. If the vulnerability is published, it can be detected very quickly and a fix is offered. Our task was to provide the cybersec architects with a convenient control tools for inventory use, just knowing how many services have been launched, which components the services have, and those tools to handle the vulnerabilities. Quick search, prioritization, and elimination of vulnerabilities. We spoke about 4sec dependency track and preview. The code analysis was done. Now I'm going to speak about container security monitoring. It's embedded in the classic model of DevSecOps. With it, we work at 4 stages of this process: release, deploy, operate, and monitor. At the release phase, we analyze the containers and packages. At deploy phase, we scan for dependencies. At the operate phase, we analyze the containers launched, which we use for identify and look for dependencies and vulnerabilities in them. So basically, altogether, it allows us to monitor everything at the monitor phase. You need to remember that as we implement control of and monitoring of security in the pipeline, it may slow down the development of the product and the delivery of the product. So we wouldn't want to slow it down. We would like to make sure that the security control, cybersecurity control, remains invisible for the user. We immediately decided that we're going to create our own open source based solution. The main reason for that was the absence of the suitable solution in the market. High load, because Dzen is the biggest content platform in Russia and it has its own specifics. But with the open source solution, there are other advantages as well. For example, you can use it on different infrastructure of the clouds in case of Dzen. We develop inner expertise, we becoming more technologically independent, we're not connected with one single stack, we become flexible in adjusting the bugs of the application code. We can fix the bugs on our own and not wait for the patches from the vendor. So lots of vendors are stopping their activities in Russia, so becoming independent from them becomes necessary. The first open source tool we used is Trivy. Aqua Trivy is the famous one developed by Aqua Security to search for vulnerabilities and search for mistakes in the configuration. Trivy has a large spectrum of tasks, but it's much more interesting for us to find the dependencies and vulnerabilities. Trivy can be used as a console app to look for vulnerabilities in the file systems, repositories, Kubernetes, etc. On the slide, I'm showing you the Velma Linux command with a simple command and the name of the image, and we get the list of the dependencies, CVE, the level of the criticality of vulnerabilities, which version is running right now, and which version fixes the vulnerability in actual fact. The second open source tool that we used was Dependency Track, which is a platform to manage security. Dependency Track has a few vulnerability analysis tools, and the dashboard of it shows the overall view the recommendations to fix the vulnerabilities and the list of the projects and the level of their security. To scan the images, dependency track is not used. Normally, it's used to manage the vulnerabilities, but it occurred to us that we use dependency track exactly for scanning of the images. Let's just take a look at the solution itself, and then we'll have a more detailed approach. The solution includes 4 components. The scanner, which is goal-based, with a planner and scheduler, which contains information about images in the cloud. With the Trivy, it creates the SBOM and sends SBOM to dependency track for further vulnerability analysis. To scan for vulnerabilities and for risk management, the analysts would have to be provided with a convenient analytics tool. Dependency track was chosen for that, which shows the actual state of the dependencies, their vulnerabilities, and it reacts quickly to the critical ones and sets the priorities of the vulnerabilities right. However, our experience tells us Trivy does this better than other also embedded in dependency track scanners. So let's say a few words about Trivy. Trivy has the API, but that API would not allow this to work with the vulnerabilities database. So we brushed this up, improved it, and we created Trivy REST to get access to the database with the REST API, and dependency track is done not just in their own scanners, but in Trivy. So we provided for automated scanning of the components and obtaining the results of analysis in a proper way. SBOM is the key element of the process of detecting the vulnerabilities. It includes files, dependencies, libraries, and all those things that are related to either the service or the infrastructure as such. Its task is to provide the complete information about dependencies, about the versions, about the types of the licenses, on condition that this SBOM is there, and also there is a reliable database of the vulnerabilities types, so you can easily come up with the list of the vulnerabilities of the exact list. If not, you will have to do the calculations separately, so sometimes it's difficult for some non-transparent components. The mechanism includes the scanning tool, in our case it's Trivy, and creating of the SBOM. By creating an image or by directly using the preliminary calculated SBOM. And further on, the scanning tool compares the vulnerabilities from different sources and comes up with the end list of the vulnerabilities of the exact image. If we describe the task for scanning for vulnerabilities, we knew that we would have to store SBOM somewhere. So we chose CycloneDX format for that, because CycloneDX was supported by Trivy and dependency track, by both of them. We use this for dependency track, and it contains the information about metadata, components, dependencies, vulnerabilities, relationships. So we find this out when Trivy gets the package for vulnerabilities analysis. The vulnerabilities field is filled in. So what could go wrong? We would do this with CycloneDX and send the dependency track for further analysis, and it would scan them. Of course, it would scan them, but according to our experience, not a very good experience, it would not. So we decided to use Trivy for the vulnerability analysis, and plus the fact it scans OS packages very badly. But let's just analyze the analysis of the dependency track. Why did we decide to do that and not to take the existing ones? Dependency track has a few services to reveal the vulnerabilities. First of all, the internal one, it uses the sources of the vulnerabilities that are related to dependency track, like OSS index, free of charge analyzer, VULNDB, which is a commercial service, and SNCC, commercial service. We can't use these two. So we will consider the sources of the vulnerabilities in dependency track. And that's NVD, GitHub Advisor source, NVD, CPE matcher. We didn't want CPE matcher, of which I will tell you at the next slide. And GitHub Advisors support fewer systems than Trivy. As far as CPE is concerned, there were lots of false positives. We would do the matching for vendor, product, and version, and vendor would often fill the form out in the wrong way. So we only had the product plus the version. Other fields would not be able to match properly. And in the ecosystem, the packages were not considered. The ecosystem was not considered. Here's the example when the RASP packet manager was matched with the desktop application for Mac. And there are plenty of such examples. But as far as the sources of the Trivy vulnerabilities, one of the advantages of Trivy is that it has an open repository where they take vulnerabilities. And what's important is that it supports a large number of Linux distributives. And a couple of words about why it's important to collect vulnerabilities from different sources. Linux distributives have their own vulnerability lists. Ubuntu has its own vulnerability lists, etc., etc. All these lists look like big XMLs. Trivy downloads them and puts them in the vulnerability database. On the slide, you can see the CV reports by Ubuntu. In other words, Linux distributives are different with the versions of the packages and the set of the patches. So the RPM or depth versions are set by the developers, and the containers may apply the patches. Overall, we need to understand that somewhere the vulnerability is patched and somewhere it's not. One of the adjustments we applied to Trivy was parsing package URL. It's a very simple code. It just fits in one page. It starts with the database initialization, package URL, and vulnerability detection. You can also parse OS packages, but with those packages, there was a problem. With the BOMDX format, dependency track ignored the properties field. The properties field was just dropped, which is specific for Trivy. So we brushed it up a little bit. We improved this parsing properties, and we created a column to keep the properties. That's where we put the raw JSON. So how does the parsing occur? On the right-hand side, there is some parsing, and on the left-hand side, there is detect for vulnerabilities detections. So what was the solution overall? Dependency track had a properties column added, and clone dx bomb was also fixed. And also here we added parsing com assurance and separate scan of the OS packages. We wrote our own scanning scanner, which collects the relevant information about the images in the cloud. And SBOM just need to be assembled once, so the cloud very quickly is checked for vulnerabilities when new images are added. And the use of the planner, the scheduler, allows us to do the ongoing monitoring of the vulnerabilities, and you no longer need to do this manually. Ultimately, that's the solution that we ended up with. The same could have been with the SIFT plus GRIBE, and we could use that instead of this solution for dependency track. The scheme for monitoring of the security of the containers works like this. First of all, you analyze the list of the launched images in the cloud, which provides for the actual list. Then the scanner gets the information about every image from the registry. As a unique ID, we have the hash sum digest. Then there is a scanner with the trivia. It gets Cyclone DX and sends it to the database. Then the dependency track is created and the SBOM is sent there. Old SBOMs and new SBOMs are sent there because database is constantly updated, so we'll have to rescan the existing images. And number 5, dependency track with the trivia REST analyzes vulnerabilities. The Dzen images are deployed in the cloud. So the container monitoring system is also deployed in one cloud. Of course, you will have to spend a lot of time to speak about one cloud. It deserves a standalone presentation, so I will just do the highlights of the one cloud solution. You can follow the details by using the QR code on the slide. One cloud was developed by the classmates, social media, Одноклассники. They are independent from one another. Each cloud is made of 7 clouds, where each cloud lives in a separate data center. The one cloud services, we use base images. Base images are deployed in a standard way. We used base images based upon Oracle 9 solution. Oracle 9 solution base origins include monitoring, configuration delivery, comp FP, errors check, and login, connecting to instances, and many others. One cloud is made in a way that at any point in time, any cloud can shut down. So there is no guarantee that some containers will be launched at a certain point in time. So therefore, we had to think about redundancy and reliability. So we created the redundant Postgres cluster. We balanced the scanner and trivia REST, and dependency tracks is still not independent and fault tolerant. But I would like to imagine that it could be done and it could be explained. If you use Kubernetes, it could be done with a pattern operation. The system is deployed in an isolated contour. Here we can see the tools for deploying the fault-tolerant cluster. Patroni manages Postgres. It's used for replication, backup, copying, and recovery. etcd, it's fault-tolerant key storage, which stores the state of the cluster. By using Patroni, Postgres uses them, uses etcd for the work of the cluster, for the proper work of the cluster. But we also needed a method which would help us to connect to the master. And this method is shown by the hub proxy.
Клиенты Postgres подключаются к
The Postgres clients are connecting to hub proxy, and they are connecting it to the nodes in the cluster. Three clouds are used here.
это расположено в своем облаке.
Each node belongs to each cloud, and the scanners are also in three clouds. But the dependency track is only in one cloud because it's not yet fault tolerant. And as far as balancing of the Trivy REST, Trivy REST has a database which is a BoldDB file, which is a light file, which is uploaded just once with the first installation of Trivy, and then it updates on a regular basis. It updates daily. Trivy REST is independent on other components, and each request is also independent. So that's why I should say that we created a few copies of Trivy REST, and the inquiries are distributed smoothly across the board. However, we should say that dependency track is the thing that we don't very much like in terms of fault tolerance and the functions. We decided to improve it so that it meets our minimal requirements, but there are many more steps to go to improve it. We just need to work on fault tolerance, UX, search for vulnerabilities, filtration. We need to work on UI, we need to make it faster. Possibly we will also work on the dependency track, or maybe we'll create our own system, but to have our own homegrown system is an expensive solution. Using the dependency track is cheaper, but we have a lot of specifics. Like, for example, we have separation by business units, we send the data to Prometheus, etc. Let's speak about the results. Scanner scans 200 images for 30 minutes with the minimal impact on the cloud, because there is no deployment, because if it's part of the deployment, it can reduce the time to market, which is not desirable for the business. You should scan on standalone computing power. We selected the strategy of isolating of the resources called batch. So we will provide as many resources as they were requested, and they are free from fraud tasks. We scan only the launched images because the full scale of all of the images of Dzen may last for more than 24 hours. We also covered some inventory tasks, and work handling vulnerabilities. This monitoring system may be integrated easily in the security processes in any infrastructures like Kubernetes and things like that. Even if it's a functioning tool, it allows the efficiency of interacting cybersecurity team with developers, especially when they have to set the priorities right, eradicating vulnerabilities. And we already adapted this to another cloud. And that's why we decided to share these examples with you. So, this is it. I'm done. I'd be happy to take your questions. Thank you. A round of applause, please. Thanks. That was a big topic, a complex one. Remember that you may be getting gifts for your questions. Let me use my right as a moderator. VK decided to drop Kubernetes for the sake of one cloud, your own solution. How did it affect cybersecurity? Could you please repeat your question? I was drinking water. VK dropped Kubernetes as a standard for the sake of your own one cloud solution. How did it affect cybersecurity? Seems like the Kubernetes is an open source solution, so it's detecting the vulnerabilities quite quickly. Aren't you afraid of something being buried there deeply? No, because we always track the security, and for the sake of one cloud, I should say that it's a very convenient system. So you could have read about that in my QR code link. Are you going to move it to open source? Whether we are going to move it to open source, okay, let me try an answer. So far, we are not ready to give you this answer because we are in the pipeline of the development cycle. And whatever you say, you would like to create a high quality product. When it's ready, we'll think about whether we'd like to open source it or not. Okay, we have the questions in the bot chat. The first question, I read it 3 times. I don't understand it. Three age transitives. How do you use them? But I don't understand. Can I read this myself?
Ну, я напомню, что я все-таки в первую очередь...
I'll remind you that first of all, I'm a programmer. I'm not an information security expert, and a lot of cybersecurity aspects are not familiar to me. Actually, I don't understand this question myself. I was even going to skip it. Okay, next question. Why do you need such a complex chain? 3 types. Is there any point of having dependency track? Yes, there is a point, because that's the platform which allows the architect and the analysts see the information, set the priorities right with vulnerabilities by the real risk. It's a very convenient system to manage the security. Next question, you use dependency track just to visualize the life cycle of vulnerabilities. Why is only that? Wouldn't that be more simple to get the trivia report and use defect dodger? We had a very nice experience of using dependency track and trivia. No, we think that it's a very convenient tool for visualization. Regardless of that, it has advantages, some disadvantages. It also has some advantages. But any task has more than one solution. Any type of ways of tackling that can be applied. That's why. Why did you choose Oracle as the base image? Oracle 9. In OneCloud, there are base images already, and Oracle being one of the most frequently used ones. So we think that we'd match OneCloud practices, and this is it. Thank you. We run out of questions here, but we have more questions on the floor. Don't forget, you're going to get some rewards for that.
Здравствуйте, Татьяна. Спасибо.
Hello, Tatyana. Thank you very much for your presentation. A very interesting solution that you're coming up with.
Михаил Александрович из университета ИТМО.
У меня следующий вопрос. Mikhail Bachov, and I have the following question. You claim that as you introduce the vulnerability scanners, it reduces time to market. But it seems like that you have created a tool for analysts where detection is not going along with reacting. You just pointed out that you're a programmer and you'll be able to say how it all works. So in the pipeline case, the developers are not able to roll out the vulnerable image to prod. But how do you react to that in your system? Would you react at all at the vulnerable image? So the developers learn immediately that their image is vulnerable and they cannot roll it out further on. Okay, thank you for your question. I think it would have been more correct that we do not claim, but we highlight the negative lines in the pipeline. We have a team of analysts working there who check for vulnerabilities with their own eyes, and they set the priorities of them based upon the real risk, and they give this task to the developers, and developers very quickly do the fixes. And this does not take a long time because we're in a very good relations with the developers, by the way. All right, thank you very much. Do the developers often say no to your pull request.
Друзья, еще вопросы?
Never,
Пожалуйста.
because I write
Руки
it
ваши вижу.
nice from the first attempt.
Здравствуйте, я вот хотел спросить, а вот
Hello,
можно
the next question.
самостоятельно проверить
What
кластерные
about
статистические
a newbie? How can a newbie check the cluster for most critical vulnerabilities?
создавать свой
And also you said that you are possibly going to create your own scanner. How much time do you think it's going to take and how many people in the team?
Часть вопроса, сколько на что потребуется много времени?
How much time to take for what? To create your own vulnerability scanner, like I said.
С нуля.
Написание сканера.
If you start from scratch,
Ну, смотрите.
if you start from scratch to create such a vulnerability scanner, actually it took more time for us because we conducted the research. I just explained the main principles of this task, so you and other participants of the conference can do it faster. But as for the development part, more than 3 people from the team were involved in that, and I don't remember about the time, less than a few months, less